Let us start with the 14th question of Zettili, and let us first analyze the question. The question states that the initial state of the system is given, that is at time t equals to 0. This is the system state equation, and phi 1, phi 2, phi 3 and phi 4 are orthonormal energy eigenfunction, which means that phi I, the inner product of phi I and phi j is delta ij, and delta I is the Kronecker delta function. Okay, now the first question is asked that if the four ket are eigenvectors of Hamiltonian with energies E1, E2, E3 and E4, then we have to find what will be the state of the system at later time. Okay, so given psi 0 and to find psi at time t, and one way to go about this is this. So the way to go about this is using the time evolution operator on psi naught. So let's say some phi t equals to some time evolution unitary operator acting on phi 1t and phi 0. Okay, and this is nothing but e to the power I e1t by h cut into psi 1. Okay, and there is just one property you should remember, that if psi 0, psi at 0 equals to lambda 1 phi 0 plus lambda 2 phi 1 0 and lambda 2 phi 2 0, then phi of t equals to lambda 1 phi of t, phi 1 of t plus lambda 2 phi 2 of t. Now applying this very property to our psi of t, we get one by root 3 phi 1 of t plus 1 by 2 phi 2 of t 1 by root 6 phi 3 of t plus 1 by 2 phi 4 of t. And we know how to calculate phi 1 of t, phi 2 of t using the unitary operator. So our psi of t becomes 1 by root 3 e to the power minus I e1t on h cut phi 1 plus 1 by 2 e to the power minus I e2t by h cut phi 2 plus 1 by root 6 e to the power minus I e3 t by h cut phi of 3 plus 1 by 2 e to the power minus I e4 e3 e4 t by h cut phi 4. So this is the value of system in the later time t. Alright. Now what are the possible results of measuring energy of the system with that, and with what probability will they occur? Okay, so for any EI, probability will be phi I into psi whole square upon phi I upon psi norm. This is nothing but the norm square. Okay, now for E1, probability will be, so one thing you can actually calculate by inner product of psi is that psi is 1 for this given example. So I will just, instead of just writing time, I will just remove this so that there is no more confusion over here, because anything divided by 1 is the number itself. So for this we will be having the answer 1 by 3, because when phi 1 multiply with phi 2, phi 3 and phi 4, it will just give us value 0. Similarly for E2, our probability is 1 by 4. E3 probability is 1 by 6. For E4, probability is 1 by 4. So these are the 4 probabilities, and if we measure the energy of the system, then we have the average energy as let's say my average energy as summation pi ei, summation is over I, so p1 e1 plus p2 e2 p3 e3 p4 e4. Okay, now p1 is 1 by 3 e1 plus 1 by 4 e2 1 by 4 1 by 6 e3 1 by 4 e4. Okay, now we are done with the first two questions, and in the third question we are asked to calculate the expectation value of Hamiltonian at time t and time t equals to 0 and time t equals to 10 seconds. So first I will calculate the Hamiltonian at time t equals to 0. So that is nothing but psi 0 h Now one thing that you should remember is, when Hamiltonian is applied on some phi I, it gives value ei into phi I. Okay, now we are applying this Hamiltonian on psi 0. Is h by root 3 phi 1 plus h cap by 2 phi 2 plus h cap by root 6 phi 3 plus h cap by 2 phi 4. This gives us e by root 3 phi 1 plus e by 2 phi 2 plus e by root 6 phi 3 plus e by 2 phi 4. We can take e as common, so h cap on psi 0 sorry, I have made a mistake over here, that so this is my mistake, I admit. Now the expectation value of Hamiltonian at time t equals to 0 is nothing but this. Okay, and this is the Hamiltonian at t equals to 0. We have to calculate the Hamiltonian at time t equals to 10 seconds. So as of now, let me write first psi at time t. One by root 3 to the power minus I e1 t by psi 1 the whole equation becomes now one thing to remember for this time dependent psi is when Hamiltonian operates on any phi t gives us e. Let me write it more clearly. Some Hamiltonian operates on some phi I t and gives us ei into phi I t. Now we apply the Hamiltonian to this equation over here, h cap whole into h cap. So we get 1 by root 3 e1 e to r minus I e1 t by h cut e2 by 2 r minus I e2 t by h cut plus 1 by root 6 e to the power minus I h. Okay, over here e3 I have missed, e3 t by h cut plus 1 by 2 e by 2 minus I e4 t by h cut into phi 4. So this is our h cut working on psi of t, and our bra of psi t is nothing but 1 by root 3 e to r plus I e1 t by h cut phi 1 plus 1 by 2 e to the power plus e to t by h cut phi 2 by root 6 e to the power plus I e3 t by h cut phi 3 plus 1 by 2 e to the power plus I e4 t by h cut phi of 4. Now applying phi t, h and phi of t. Now going through the whole calculation process, we will find that it reduces to e, this simplifies to e1 by 3, e2 by 4, e3 by 6, e4 by 4. Now over here you might have noticed that the same expression we have got earlier for psi 0. So from these two equations we can say that the expectation value of Hamiltonian doesn't change with time. So expectation at t equals to 0 will be equals to expectation at t equals to 10, which will be equal to e1 by 3 plus e2 by 4, e3 by 16 plus e4 by 4. So this is the answer for the third part. I am extremely sorry for the blunder in between that I made over here in this slide, but I hope I could rectify that with a proper explanation. So thank you for watching the video.